Hello everyone. Uh, Greetings to all. My name is Santosh from second CSC. Today my topic is empirical estimation and techniques in software engineering. How we use empirical estimation and how it used in Cocoon and some techniques in how software engineering developments on techniques, how it involves, what is empirical estimation in detail, what is empirical estimation techniques. Let me know in detail. Empirical estimation techniques involve using observed data to interpret values or parameters in statistical models. These techniques are crucial in fields like economics, medicine, and engineering for making predictions. Under these methods, enhancing decision-making process based on real-world observation. After that, importance of empirical estimation. Empirical estimation provides a practical approach to model complex relations to data. It allows researchers to validate theoretical models against actual observation. Here we understand that is we are analyzing validate theoretical models against actual observation. That is theoretical means where we are analyzing observation with comparing our ac- uh, actual observations. This techniques improving accuracy in predictions and analysis where we are predicting the budget or anything some else. After that, types of empirical estimation techniques. Common types of including ordinary least or squares, ordinary least squares, maximum likelihood load estimations, and basement methods. Each method has its own assumptions and application. Applicability depending on the data and model structure. Understanding difference help in selecting the appropriate method for a specific research questions. After that, we have to discuss how empirical estimation will work. Let me clearly explain about ordinary least squares. Is a method used to estimate parameters in linear regression models. It is related to probability statistics, where we learn in detail regression, regression by solving regression, how the problems are solved easily. It is a minimum the sum of square difference between observed and predicted values. We it is simply we explain observed frequency minus square of predicted by based on this formula we analyze easily how the going on how the our empirical estimate process going with using step ordinary list squares. Ordinary list squares is a widely used due to simplicity and efficiency estimating the linear relations. Here we highlighting to the linear relations. These are not complicated, but these are somewhat linear to what we are analyzing our problems in a project. Our project manager, how we analyze the present situation or techniques. After that, maximum likelihood estimation. It means it having complicated or very highly solvable problems or anything we are using. In that case, ML's method estimates parameters by maximizing likelihood function. It is widely applicable, especially in complex models where OLS may not be suitable. May some cases it be highlighting that complex models, we simply say that the ordinary linear squares used for linear problems or simple problems. It used for complex and very difficult problems or difficult analyzing empirical estimations. Here, particularly powerful scenarios involving non-normal data. It means maybe it is a complicated data with graphs or any distributing models with high quantity or bulk amount. Next, we explain about Bayesian estimation. Bayesian estimation combines prior information with observed data to update belief support parameters. This method provides a flexible framework for incorporating uncertainty in parameter estimation. Basis techniques are increasing popular due to advances in computer methods. Here, advances refers to it is in advance compared to the complex and linear. It having some similar to some are more, which we use highly effectively. It using mainly a prior information. We have to understand that prior information we are comparing to maximum level and ordinary level. After that, non-parametric estimation techniques. Non-parametric not assume the specific functional forms for uh, data distribution. Example, kernel density estimation and nearest neighbor methods. These techniques useful to underlying the distribution unknown or complex. We but like comparing or we discussing past types of empirical estimators. For in that we having CR used for every case, but this is used for everything until we don't know about unknown data or complex data. It's simply used for in probability statistics, test series or test distribution. In the topic, we gather or we learn more information. After that, bootstrap methods. How the methods are used. Bootstrap is a resampling technique used to assess the accuracy of sample estimates. By repeatedly resampling from data, it allows for estimation of confidence intervals, standard errors. This method is particularly valuable when traditional assumptions of normality cannot be made. It's simply which we can't assume or we can't think or we can't impossible to do the projects that are used by bootstrap methods. Like here, mainly understanding assumption of normality cannot be met. We are never that are easily understandable or which we are confidently we not estimated. After that, comparison of techniques. Each empirical estimating has strengths and weakness depending on context. OLS is efficient for linear relations, where comparative equation better complex. Absolutely. Non-parametric and bootstrap methods are provide flexibility mainly, and when the assumptions are not satisfied. Of course, after the application in real world, empirical estimation techniques are used in various fields such as finance, healthcare, and social science. In we highlighting finance is more important, where comparing everything, very documents or everything in which is important. In social science, in general, also in financial, they help in risk assessment and model stock prices. After that, healthcare suggest understanding treatment effective and patient outcomes. After the challenges in empirical estimations, these can be leads to basement estimation inaccurate conclusions and dealings with measurements errors or missing data and model specific issues. After finally, we conclude that estimate is vital effective data analyzing and decision making. As computer power increases, the application of these techniques will continue to evolve. Future development may focus on integrating machine learning with the traditional empirical methods for enhanced accuracy. Thank you for giving golden opportunity. Okay.